And the idea of waking up too, I think, is a very important one here. I think that since we were talking about earlier that we may be just the one looking at itself through avatars. Right. Yeah, there's some deep intelligence here. Well, entropy could come around from our ignorance. Entropy is
Well, well, thank you, thank you. So how would you define entropy?
that's evolved randomly. That doesn't work, and especially when now our physics is telling us that space-time itself is doomed. That whole framework just goes out the window.
So let me just ask you a very blunt question. Do we live in a simulation?
Well,
Donald Hoffman, professor. It's so good to have you here with me, and I'm so thrilled to see you again.
Robert, it's great to get together again. I've loved our times together.
Yeah, it's never boring, that's for sure. It might be for everyone else who doesn't want to speak the language of math, but definitely for us. I mean, it's been, at least for my side, it was good for me. I've enjoyed our conversation. We had dinner together, and I knew that we were going to be fast friends. And also, I really love your way of looking at life, and philosophically, sort of speaking, and bringing meaning to the math. And I think that's one of the things the world is really, really needing badly. But I'll just say, Donald Hoffman is a professor of neuroscience. He's at University of California, Irvine. Has been a tenured professor there for how many years now?
Started in 1983.
That's a bit of time. That's definitely a bit of time. And he's probably the world's expert, I would say, and I would argue, probably the world's expert on mathematical mapping of human consciousness and awareness. And so I'm fascinated on this particular topic because I believe that we live in a U inverse, and it's associated with my experience, and you have your own U inverse, and you have your own. I purposely don't call it a universe because I feel like it's a reflection of what's happening inside of us. So
Okay.
it's literally like an absorption, reflection, spectral analysis differentiation that's then projected back. And so that, of course, means that you've got thought that's in our conscious mind, and you've got thought that is in our subconscious or unconscious mind. And maybe that's what we're actually calling the universe around us. And you can't separate. We don't see that they're connected, but maybe actually they're very, very connected. And we just don't know how to make the connections, which then answers things like how we get synchronicities and everything else. So I was just fascinated when I first came across your work, and how you looked at things. I first came across your work. I watched one of your TED talks,
Yes.
and I was fascinated by the whole discussion in that. And I really feel that the way that you have categorized this topic of let's not be fooled by our senses is such a powerful and poignant thing that we're all dealing with today, as so many of us are starting to figure out, wait, what I thought was objective reality may not actually be objective reality.
That's right, and it's even in physics. It won the Nobel Prize last year, right?
Yeah,
The three winners of the Nobel Prize
local
got it.
realism is false.
Local realism is false. You
So
know,
tell us about that. What are your thoughts on that? Was that surprising to you, or is it just a matter of time in your thinking?
well, I think no physicist was surprised about by the Nobel Prize was for John Clauser and Alan Aspect and Anton Zeilinger empirically um, demonstrating what quantum theory entails, right? So they're
Entanglement. Mhm.
testing the predictions of quantum theory that local realism is not true. And maybe people don't know what local realism means. So locality in physics means that no influences propagate faster than the speed of light through space-time.
Mhm.
And realism is the claim that objects like particles, protons and neutrons, electrons, so forth, have definite values of their positions and momenta when they're not observed. And most of us would intuitively think, well, yeah, I mean, those particles are real, so they have real values of their positional momentum. It doesn't matter whether someone observes them or not. And it turns out that the conjunction of locality and realism, which is called local realism, um, um, is false empirically. And so that's what won the Nobel Prize. My own view is that both that realism is false, so, and that locality um, um, is false in the sense that physicists are now telling us that space-time is not fundamental. So locality is a property of space-time, but space-time itself is not a
So
fundamental
that
object.
means then distance and time itself is illusory.
Yes, it's at best like a data structure that we use, but it's not the objective reality. And physicists are now very busy. The new generation of physicists are very busy looking for structures and finding structures that are entirely beyond spacetime, not curled up inside spacetime, not little dimensions curled up inside spacetime, but structures entirely outside of spacetime that project down to spacetime. And spacetime, from my point of view, then looks like a fairly trivial data structure that's a projection of these deeper structures. So yes, I mean, we all have assumed intuitively that space and time, or space time, and then the objects in space time, is the fundamental nature of reality. But that goes against our best physics now, the best physics that's winning Nobel prizes, and will win future Nobel prizes as we find, as the physicists find new structures beyond space time. Like, for example, the amplitude-hedron and decorated permutations, and EFT-hedron and so forth. They are findings. So it's not just a hand wave that space time is incomplete somehow. They're going beyond space time and finding new structures that allow us to predict the scattering amplitudes for collisions in the Large Hadron and Collider and so forth. Predicting the scattering amplitudes for these collisions in space time, but using a mathematics that's entirely beyond space time, and a structure beyond space time.
So wait a minute, let's just rewind for a moment because I grew up in a world, I'm assuming you did as well, where materiality and materialism was sort of the foundational tenet of pretty much what we consider science today. And I have always believed that, mathematics as an applied construct becomes geometry. So applied mathematics is geometry, applied geometry becomes physics, applied physics becomes chemistry, applied chemistry becomes biology, applied biology becomes psychology, applied psychology becomes sociology, applied sociology becomes philosophy, and applied philosophy comes back to mathematics. And so as we sort of think about this, there's literally nothing that doesn't get impacted in our understanding of what the word science even is now, because
Right.
physics is what underlies chemistry. So then clearly, if applied physics is chemistry and then that informs biology, then all of our material, quote unquote, material sciences need to be looked at in a different context now.
That's entirely right, and that gets at the whole notion of reductionism, which has been a central and powerful approach that science and physics has taken. The idea, the reductionism has various meanings, so I'll say exactly what I mean. By reductionism, I mean that the idea that as you go to smaller and smaller scales of space and time, you find more and more fundamental entities and more fundamental laws governing those entities. So that's what I mean by reductionism. And that reductionism, of course, was spectacularly successful in, for example, statistical thermodynamics, where we
Hmm.
have the notion of heat and pressure and so forth. And we're able to reduce those to the dynamical behavior of unseen molecules,
Hmm.
and the Boltzmann distribution and so forth. The and so there are spectacular successes of the reductionist approach. And some scientists had hoped that we would be able to go on ad infinitum with that reductionist approach. And it turns out, no, you can't. And the space time is, in my view, a very shallow structure. It falls apart at 10 to the minus 33 centimeters and 10 to the minus 43 seconds, the so called Planck scale.
Hmm.
And after that, it has no operational meaning. So it just falls apart at only 10 to minus 33 centimeters, not 10 to the minus 33 trillion centimeters, just 10 to the minus 33, not 33 trillion.
Probably because that would be the smallest LED in our giant giant matrix screen that we're all living in.
Yeah, yeah. Some people do think about it as sort of like the pixels. Others would argue that at least it's not coherent to talk about pixels because the notion of Lorentz invariance couldn't really hold if you had these fixed pixels. What would they have a fixed size in whose reference frame? You'd have a problem with reference frames and so forth. That's a big open question. But however you come down on that, the idea is that at 10 to the minus 33 centimeters, it's over. Not 10 to the minus 33
Yeah,
trillion,
and
just 10
and
to the
that
minus
doesn't really make
33.
sense. It's like why physics, I think, for so long has still been separated in this chasm between, this whole strong nuclear force versus gravity and weak force, and it just doesn't seem to foot. It's hard to comport how this actually happens. Why is it that electromagnetism and gravity, which both adhere to the inverse square law, do so only in the macro scales, but not in the micro scales? And that is one of the big chasms that literally has separated physics, in the quantum versus classical models. And I'm hoping that someday someone's going to figure out how to renormalize that.
Right. As we were talking about just before we went on the podcast, the renormalization is the field that physicists talk about here, where they're trying to get effective field theories at different scales, and that approach has worked fairly well, to the extent that they've been able to push it. But they also have a problem that they know is a big problem. It's what they call the vacuum catastrophe,
Yep.
and we hear about quantum field
Which
theory
I love the
making.
way they say that. It's like this vacuum catastrophe. Oh my gosh, such a catastrophe. They kind of like a little bit of drama on that one. I'll
Well,
give that to them.
Well, it is dramatic,
It's
and
dramatic.
for them it is a they know that the vacuum catastrophe is telling them that there's something very deep that needs to be changed in the whole theory that they're doing. There's some deep concept that they need because their predictions about the what's called the mass energy density of the vacuum,
Hmm.
essentially how much energy there is just in the raw vacuum. What you know they have their theoretical prediction from quantum field theory,
Isn't
and
that
then they
also
have the empirical.
synonymous with? So that could also be called the Planck density of the vacuum, right?
Well, it has to do, yeah. Well, the Planck energies are going to be play a key role in the whole thing.
I think
Absolutely.
it's something like 5.16 times 10 to the negative 93rd power, if I remember correctly. But it's Planck density and Planck energies. Yeah, definitely. But keep going with that. Keep going.
Right. So normally when physics makes a prediction from their theories, they would like to point out that they're pretty close usually. Like we can get the magnetic moment of the electron or the
The Big
muon
Bang
to
and
like
right. It was
8 or
exactly
10 or whatever it is
13.8.
decimal place.
Right.
It's
Mhm.
one part in a billion. They're right. They're only off by one part in a billion or something like that. But when it comes to their predictions from quantum field theory about the mass energy density of the vacuum, it's not that they're off by one part in a billion, or even one part in 1,000, or one part in 100. Um, they're off by something. It's not just off by a factor of 10 or 100 or 1,000. They're off by a factor of 10 to the
To the
120th
55.
power.
Oh, 120th. Yeah, that's right. That's right.
So they, there's just no escaping that there's some deep conceptual leap that we need to take. Now, physicists are taking a deep leap beyond space-time. There are, so David Gross in a 2005 paper celebrating the 100-year anniversary of Einstein's special theory of relativity, he first praised Einstein, of course, wonderful gift that Einstein gave us, but then said space-time is doomed. Right in the same paper, he says space-time is doomed, and a number of other major physicists, including Nima Hamed and Nathan Seiberg and others, are agreeing. Space we need to go beyond space-time, and I think that they'll have to do that to get past this vacuum catastrophe. You'll have to go to a deeper framework, and that projects down to space-time, and then you'll understand how to get around the vacuum catastrophe.
So let me just ask you a very blunt question. Do we live in a simulation?
Well, let me say the answer in a little way. I'll hedge it a little bit. My first answer would be if you take evolution by natural selection seriously,
Mhm.
Suppose and we ask the question, what is the probability, given that theory, that our senses were shaped by natural selection to show us true properties of objective reality? What is that probability according to the theory? And the answer is the probability is zero.
Very yeah, yeah, it would kind of be in the category of where you would expect it for something like chaos theory or something. It's not gonna happen. It's like me taking apart my watch and putting it in a bag and then shaking it, and what's the probability that's gonna come back as a watch if every piece has already been taken apart?
Right, and of course, the rejoinder that evolutionary theorists would have to that kind of analogy would be to say that, of course, evolution isn't just about shaking the parts and so forth. That's a full on just random thing. There is this selection process that sort of cuts down the search space. But what I'm saying is, even if you get rid of the just complete random thing and take full evolutionary game theory, the modern mathematical theory of evolution by natural selection, and use that and ask, what is the probability that any sensory system would be shaped to see any aspect of objective reality correctly, truly? The probability is precisely zero, and so that, and I should say a little bit about why it is the case, but to first answer your question, that suggests to me that what evolutionary theory says on its face, which is evolutions shape sensory systems to guide adaptive behavior. That's what evolution says. And I completely agree with evolution that it does, the mathematics does do that. It shapes sensory systems to guide adaptive behavior, to keep you alive long enough to reproduce. That's
Mhm,
what I mean by adaptive behavior. So it does that. And that has nothing to do with seeing the truth. That just has something to do with guiding adaptive behavior, period. And seeing the truth is something entirely different. And so, in that sense, what evolution has shaped us with is a user interface that hides the
ah,
truth. So that's in that sense. Now I would say yes, I agree with you. It's like a simulation in the same sense that when I'm playing like Grand Theft Auto, right?
mhm,
I'm interacting with a user interface that's very fun, but the red Porsche that I see in Grand Theft Auto is nothing like what the reality I'm interacting with, which in this metaphor is some supercomputer that I'm interacting with. And there's no, if you look inside that supercomputer, you'll see circuits and software, but not a red Porsche anywhere inside that. And so what you're seeing in Grand Theft Auto is what you need to guide adaptive behavior in playing the game of Grand Theft Auto. That's what you see is what you need to play the game effectively. You're not seeing the truth, and that's what evolution also says is you're seeing or perceiving what you need to play the game of life effectively, which is not the truth. You don't need to see the truth. In fact, the truth gets in the way. If you had to toggle voltages to play Grand Theft Auto, you would lose
yeah,
to
yeah,
someone who
totally.
had the interface.
So this is interesting because there's a ton of philosophical questions and an avenue I could easily go down, but I'm going to resist going down that path yet. I'll wait till we get further in to the conversation because I definitely think there's a reason then, uh, if it is a simulation as we believe, I believe that, um, that we experience world in this duality context, and that probably the only way we can contextualize something. If I said, "I wanna know the length of, this part of my glasses right here," what does this length mean? It doesn't really mean anything unless I have some context to reference it against,
Right.
right? There has to be some context. Now, we just discovered something in mathematics just today, in fact, that might actually present a possible answer for that contextual reference to provide some dimensionality to that which should not have dimensionality. It's dimensionless.
Right.
Right? So mathematical constants like pi, phi Euler, all of those can be dimensionless. But there is a way we found to be able to construct around this that then it also implies this thing is so perfectly designed as a simulation construct. Who the hell did it? I mean, this person was a freaking genius, whoever it was, and is so far beyond any level of understanding that we can even comprehend right now. So I'll just tell you what we found. So if you take a circle, so there's a concept in geometry of a perfect polygon, right? So a perfect polygon in 2 dimensions, so think Euclidean plane. And for a perfect polygon to exist, it has to have a value that will be equal between its perimeter and its area. As a circle, it would be its circumference and its area. So you would say, but wait, what circle could do that? Well, there's only one circle that can do that in the second dimension, and that is a circle with a radius of 2. A circle with a radius of 2 will have 4 pi as its circumference and area value. So it's equivalent, right? And so in mathematics, these are called equable polygons.
Okay.
Or in the case of the circle, it's just a circle, the equable circle. Have you ever heard of this before?
No.
Okay, so this is fascinating because what we found is that if you place in this part, I don't know that we can claim yet. We're doing research that we discovered this, but what we found is that if you put around that circle with 2
Uh-huh.
any polygon, the polygon that is exoscribed around that circle
Hmm.
will have the same property infinitely.
Huh. Hmm.
So I'll give you an example. So if the radius is 2, then the diameter would be 4, right?
Okay.
So the square that goes around it would be a 4 by 4 square.
Okay.
4 times 4 is going to give us the area.
Right.
And, that's also going to be 4 times 4 sides is going to give us exactly 16. So they've shared the same property. Now, we found that this is true for the pentagon, for the hexagon, all the way up. It doesn't matter what polygon you put around that circle, it will always have this property where its area will be exactly equal to its perimeter value. Does that surprise you?
Yeah, I hadn't even thought in these terms before, so that's surprising. But again, I'm not a mathematician in this area, so I don't know. I mean, that my lack of surprise may just be my mathematical ignorance. So
Well, here's the other part of it that's even fascinating, more fascinating, I think. It doesn't only apply to polygons infinitely, it applies to all polytopes. So now let's put it in 3 dimension. The only thing is that to go into the third dimension, the radius now of that circle that you started with becomes a sphere,
right,
and the radius now goes to 3.
right.
And when you use a radius of 3 for the
Or-
sphere, what becomes equal is the surface area becomes exactly equal to the volume.
Huh.
And this happens with all polytopes infinitely as well, which is like all regular polytopes, so
Wow.
polyhedra, will have the exact same property. So if I put an icosahedron or I put a cube, right? So for example, if we're going to use the
Hmm.
number 3, right? So let's make it a cube.
Right.
So then you have a side length of 6, right? So 6 to the third power would give you the volume of the cube,
Right.
and then the surface area would be for each side, right? You've got 36 times 6, which is also 216, which is equal to 6 to the third power.
Huh.
And this works for everything. Dodecahedra, icosadodeca, it works on every single
That's
possible
remarkable.
polyhedra infinitely. We're writing a paper on this right now.
Pretty cool. That's a very fascinating mathematical fact. That's really interesting.
So and as you go higher dimension, this is why I'm saying the plan behind this is so freaking genius. Don, when you see this, you're going to be like, "What the hell?" It's so perfectly planned that even the way we categorize the first, second, third, fourth dimension, that's simply a lengthening of that sphere. So in the fourth dimension it would be a hypersphere,
Hmm.
right?
Right.
And all the math is perfectly informed. So then it's no longer so in the first instance, in the second dimension, it was the area was equal to the perimeter, right? In the third dimension, it was the volume was equal to the surface area,
Right.
right? In the fourth dimension, it's the volume is equal to hypervolume.
Right. Right.
Okay. And it just keeps moving up to the next two. It recategorizes itself all the way through and it works for all dimensions.
That's right. So it's the dimension, and then the first the next dimension down that
Yes.
that are related.
Yeah. So
Right.
So then when I look at this, I'm like, "Oh my gosh, how could we even consider that entropy even exists?"
Well, in terms of being unintelligent randomness,
Yeah.
right? Yeah, there's some deep intelligence here. Well, entropy could come around from our ignorance. Entropy is
Well,
this.
well, thank you, thank you. So how would you define entropy? That's one of my questions I had on my list.
Oh well, entropy, Shannon entropy. You know, if you have a probability measure p on some space, it's say it's on a finite space of n elements, then it's the sum over n of p of x times log p of x, right? That's
Mhm,
just the
mhm.
definition of it. So it's Shannon entropy, and then there's entropy rate, and so forth for like Markovian dynamics.
Shannon is Claude Shannon,
Yeah, right,
information
Claude
theorist, yeah,
Shannon, right.
mhm.
So entropy, yeah, entropy is defined as p log p, basically, for or the sum over x of p of x log,
Yeah, but you know what's so funny? We don't have any really good measures in mathematics for entropy. All the measures we use in mathematics for entropy, truly,
hmm
even NIST has 15 I make a random number generator, and we make one with the highest level entropy,
right.
that you can have. And it's fascinating because what I found through this whole process is that really all of the measures that we call measures for entropy are really just uniform distribution measures. And they are able to operate outside of Benford's law. Benford's law being that, if you have a random distribution, let's say you grab a newspaper and you pick the number of times there's a number one, the number of times there's a number two, number of times the number three, four, five, six, seven, etc.
hmm
You're going to have a distribution where 34% of the time it's going to be the number one. So it's not 10%, 10%, 10% that you would expect, right, for
Right,
the
right.
first 10 integers. And it goes 34%, 17.5% is the number two, like 12% is the number three, like 9% is the number four. And it goes through this distribution that looks like asymptote, like we always see in math.
Yes,
So actually getting true uniform distribution is a challenge. But I don't see how, when you've got such perfection of this ordering system around the surface area equaling the volume for every polytope infinitely, when you start with a circle for that dimension that has a radius value 3, and the same is true for every polygon when you start with a radius value 2 and a hypersphere with 4 because it's in the fourth dimension. Come on.
that's pretty interesting. I'll want to look into that. So, do you think that so this is not my area of expertise? So, do you think this is a new discovery that mathematicians don't know this, or
I you know, I don't think I looked we've looked. We've looked.
okay,
My colleague Talal and I have been looking because we want to make sure, that we cite anyone who's done any kind of work on this.
right, right,
Um, but we have not found it anywhere,
okay,
especially not for the higher dimensions. We've not even found the second dimension one anywhere, not in published literature.
very, very interesting. Because I wouldn't take my ignorance about it to mean that the mathematicians are ignorant. I'm not a mathematician, so but that would be delightful if it's not been discovered before. That would be a fabulous new discovery.
Yeah, yeah, we've actually made a few. We've published quite a few, but getting recognition for this type of stuff in the community is a different thing altogether. But we just feel there's a sense of obligation we have to at least share the information when we get it, because I don't feel like I own it. I
Right,
don't,
right.
when, and I believe that any one of us can tap into a field of knowledge. If we live in a simulation, are we just AI that's becoming sentient of being AI?
Uh huh. Do you think so?
That's what I think. I think we're waking up, and it's funny because it's really quite interesting. You've heard of narcissistic self projection. And so, we tend to judge the things that we don't like about ourselves, so we attract everything we judge until we no longer judge everything we attract. And that's why it's kind of funny that now we've got this big, triggered response on the advent of AI, and we're like, "No, that's AI." And I'm like, "Well, I'm not a fan of, computers taking over our lives and AI taking over my life at all, but at the same time, it's like, is there really such thing as artificial when the entire universe is an illusion?"
Oh, yeah. Very, very interesting. Well, my take on our relationship with reality is that very much like many of the spiritual traditions, the mystical spiritual traditions say, which is that there is one consciousness and that you and I are just avatars. In fact, it as we're talking, it looks like Don talking with Robert, Robert talking with Don, but in fact, it's just the one universal consciousness using two different avatars to
Yep.
explore projections of itself. So that there's infinite number of projections of this one infinite intelligence. So the the infinite intelligence you're talking about is real. There's an infinite intelligence, but it's actually not divorced from you and me. It is you and
It
me,
is you and me.
but we've we are the one universal infinite intelligence that's chosen to peek at itself through a very limited interface where it's discovering these mathematical facts and being wowed by these mathematical facts, and somehow it needs to look at itself through projections to really understand itself. So that's
I So, okay, so
so
then I
you
have
like that
another
kind of
question
idea.
for you. I 100% agree with that. Like,
Oh,
I
thank you.
could not have said it better myself. So someone asked me recently, "What is the most valuable thing to the universe?" And I'm like, "What do you mean? Like an asset?" Whatever. It's like and he said, "No, what do you think the universe does it all for? What's the reason for doing everything that it does then?"
Right,
And I said, "I believe the most valuable asset in the universe is you
right.
and your unique individuality. That the universe observes itself through your unique eyes of perception that no one has ever had before and no one will ever have again. And because of that, it feeds its own record of information and expands itself through our eyes, through our learning. It's like building a database of all perceptual states as well as emotional states."
Yes, yeah, I think that something like again, working out the details is either difficult or impossible because we're talking about an infinite intelligence here. but 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 in broad strokes, I think something like that is right. It's the deepest idea that seems right to me. Um, the idea that we're just um, an agglomeration of particles in space time that's evolved randomly, that doesn't work. And especially when now our physics is telling us that space-time itself is doomed, that whole framework just goes out the window. So
So then what does this mean for things like the speed of light? Okay, you brought up Einstein earlier.
right, right,
My office, when you came here last time, you might have noticed that we're on Von Karman Street.
yeah,
And Von Karman, when I got the office, I had no idea what any of this stuff was related to. But Von Karman was a very famous physicist and engineer who came up with the concept of Von Karman Street vortices,
okay,
which is what we look at when we look at a hurricane or a tornado, right? And then the little eddies that come off of them, those are called Von Karman vortices,
I see.
which is fascinating. And of course, the other cross street is Michelson. That's not it's a couple streets up from Michelson Morley, right? And Michelson Morley were the two guys that
Right,
basically went and they also did some work with Einstein to measure the speed of light. And at that time in physics, there was quite a few people that believed that there was some sort of luminiferous ether that connected everything. So that there wasn't just this concept of vacuum is only vacuum. Going back to your comment about Planck density and this, the energetic density of the vacuum itself would imply that we see this even at the scale of an atom. It's like would tell you that based on the Planck density inside of that, you're going to have almost the same amount of energy in one atom as you have for the whole, what we know as the known universe. It doesn't
right,
really make sense. So this is
right,
the catastrophe.
right.
So the question I have is now with this entanglement and this latest Nobel Prize,
Hmm.
is it time to revisit the ether?
Why do you bring up the ether in that connection?
So here's why I bring it up. I had breakfast last week with Eric Weinstein, who is very very interesting fellow. He's been friends with me on social media for the last I don't know 4 years or so, 4 or 5 years, and he likes to follow my work, and I love to follow his work as well. And I think he's an outspoken advocate. He's a thinker. He's like you, right? He's a thinker. He's a big thinker.
Yes.
And he said something to me that I thought was fascinating, and it tied exactly with how I see the world. So when you're at a football stadium and you're in the wave, let's say a wave goes through you, right? And you stand up, you go like this, and then you sit down, right?
Mhm.
Did
Yes.
you travel through the stadium, or did you just have an on excitation and off excitation?
Right, essentially an on and off, you're right, right.
Yeah, the wave perturbation is what traveled around the stadium. It wasn't you.
Right,
And you are like a could be like a water molecule as well in Japan when there's a big earthquake. And by the time the wave hits California, does that mean that from this earthquake in Fukushima, does that mean that the water that came here is from Japan?
right, right,
No.
right.
It stayed in Japan, right? It's not what's here. All wave phenomenon follows this.
Mhm. Right,
So basically what that then says is that literally with each cubic segment of space or time space or space time, it's got, it's almost like an LED that comes on excitation, then off excitation, on excitation, off excitation.
mhm,
So if we're looking at like playing Pong on our screen, it's not that the photon's actually traveling at all. There's just a reflection perturbation that's happening through this excitation wave.
right.
So I this is such a fundamental aspect of physics, and we talked about this, and I'd love to hear your thoughts on, because he doesn't believe, the vacuum is vacuum, that it is actually more like the etheric field of vibrational states.
Well, so quantum field theory, of course, is the sort of the foundational theory in physics right now, for high energy physics and so forth. And there, the fields are defined over space-time, and they think of particles just as excitations, like you were talking about, excitations of the field. And so, from that point of view, the particles are not fundamental. It's the fields that are fundamental. But when they then start looking at the energy in those fields, and you go to smaller and smaller scales, things blow up. And when you get to the Planck scale, you have this catastrophe. Um, so, so my own take is that there's no reason to then start looking for some kind of medium inside space-time anymore. But
Yeah.
instead, the thing to do is to recognize that space-time itself is an old data structure,
So
and
we
it's
may
time.
never have to say the word Minkowski space-time anymore.
Well, it'll be like when we went from Newton to Einstein, right?
Mhm.
So the very notion of mass and time completely changed from going from Newton. We use the same words, but the concepts are utterly different. Um,
Mhm.
and when we go from Minkowski space-time to something deeper, again, we're going to be changing entirely. But nevertheless, we don't throw away Newton, right? When we want to go to the moon, we
No.
use Newton's equations. And I think when we
Well,
go,
and inverse square law is still correct.
that's right. It's at least, but for everyday practical uses, it's right. and and then for a little bit more complicated uses, Newton will be replaced by Einstein, and Einstein will be quote unquote right for, like for example GPS. We need to use Einstein's theory of gravity to get the GPS system to work properly. If we just had Newton's equations, GPS wouldn't work. Um, so, so we won't get rid of Minkowski space. When we actually get these new theories worked out, we don't have them yet. We have, in the last 10 years, physicists have been getting structures beyond space time, but there's no comprehensive theory yet. I mean, they're still grappling to try to get a new framework that could replace quantum field theory. That's not there yet, but they're working on it. But when they finally get it, we'll still use quantum field theory for certain problems. But and we won't get rid of Minkowski space.
But they're gonna have to find a way to close this gap on quantization of gravity, right? I'm guessing.
Well, yeah, and for that, I mean, so for example, one thing that was really a problem with Newton is that Newton um, predicts these infinities in so-called black body radiation. When you just heat up a body and look at the
Mhm.
radiation that comes from it, um, Newton's theories predicted an infinity, and there isn't any infinity. And so we're getting the same thing now with our theories of space-time. They're predicting an infinity, and there's no infinity. So We got rid of Newton's infinity by going to a bigger framework, with quantum theory and quantum field theory. Got rid of Newton's infinity, but now it has its own infinity, and we're going to have to go to an even deeper framework to get rid of that infinity. And that brings us, by the way, to a very important point about science, um, about how science works. So science has a sequence of theories, and each theory makes assumptions. Every theory has assumptions, and those assumptions are not explained by the theory. Those are the miracles of the theory. Basically, a scientific theory says, please, if you grant me these miracles, then I can explain all this other wonderful stuff. Like Einstein, special relativity required, that the speed of light is the same for all observers,
Right. Hmm.
and that the laws of physics are the same in all inertial frames. If he said, grant me those two miracles, I can give you this wonderful new uh, space-time framework to do science in, and it's been fabulous. But the key thing about science is there is no theory of everything. There's only a theory of everything except my assumptions in my theory. My assumptions aren't explained. And so if you say, well, of course, I can get a deeper theory that will explain those assumptions. Yes, but then your new theory will have its own assumptions. And so it's turtles
Yeah,
all the
and
way down.
it's kind of a this. Would you say that the scientific method is kind of a destructive construction process? It's like something has to be broken down in order to break through and become a new way of thought that's accepted.
That's right. And I absolutely agree that any good scientist would readily admit that our best theories so far are just our best theories so far. They're not a theory of everything. What a real good scientist will say, we have a theory of everything, only with a wink and a nod. Right? It's not truly a theory of everything. That's just too naive. But what's really important about science is that a good theory is mathematically precise and will tell you the limits of its own assumptions.
Hmm.
So, and that's the key thing. The point of being mathematically rigorous is, of course, to understand your theory precisely and make precise predictions, but also to avoid dogmatism. What are the limits of these assumptions? What is the fundamental limits of this framework? So, for example, Einstein's theory of special relativity and gravity assume that space-time is fundamental, and they're there to, in some sense, capture the intuition that space-time is fundamental. And quantum field theory builds on that, right? The fields are defined over space-time. So it also assumes space-time is fundamental. You put them together, and the mathematics tells you your fundamental assumption about space-time stops being coherent at 10 to the minus 33 centimeters and 10 to the minus 43 seconds.
What a
That's where your theory
surprise.
stops. Now here's
Again, for everyone that doesn't know, that's the Planck scale.
the Planck scale. That's right. Now, it's easy to fall into a silly trap here and say, surely science has fallen into a trap. It's a logical trap. It's contradicting itself. It couldn't possibly do this. So for example, Einstein and quantum field theory are are theories that the basic intuition is that space-time is fundamental. So you might say, look, so if your intuition is that space-time is fundamental, then either your mathematics successfully captures your intuition or it doesn't. Okay? Now, suppose your mathematics doesn't successfully capture your intuition. Well, then you couldn't possibly use it to show that space-time isn't fundamental. I mean, because it didn't capture, so it wouldn't count, right? So theory that didn't capture your intuitions properly couldn't be used to prove that your assumptions were wrong. But now, suppose it does capture them. Well, if it did capture them, then how could it possibly prove that the assumptions are wrong? That right?
Yeah,
So
it's
now you
circular.
so
Right.
so the very thing that I've been saying is the very heart and soul of science, which is to take our assumptions, make them mathematically precise, so we find the limits of our assumptions,
I
can be
like
turned
that, the
around
limit of the assumption.
to find the
That's
limit of that assumption, to find out. So some philosophers will come along and say, but you can't do that without being self-contradictory. And my reply is, to say that is to fundamentally misunderstand the key thing about science, which is number one, There is no theory of everything. And number two, your precise theories will tell you, in the best case, the limits of your assumptions and give you the impetus to then look for a deeper theory. Now, they won't tell you what the deeper theory has to be. That requires a creative leap. You'll always have a creative leap. Um, but the constraint is whatever your new theory is, it has to project back to the old theories that we know and love. Right. So,
Yeah.
for example, our theories of what's beyond space-time better project back and show us where quantum field theory and and general relativity come about as special cases of the more general theory. If we can't do that, then there's no reason to take our more general theory seriously. Right. It better give us back the theories that we know and love already as special cases. Um, and this argument also goes, by the way, with the argument I gave about evolution by natural selection, right? So I just used evolution by natural selection to say that it entails that we don't see reality as it is. So for example, um, Darwin, when he put out the theory of evolution, was thinking about real animals in space and time fighting for real resources and
Mhm.
killing nature red in tooth and claw. So
Mhm.
here's the argument against me. So Hoffman, you use evolutionary mathematics, evolutionary game theory, to show that objects in space-time are not fundamental, like animals and resources and so forth. So we can play the same game of showing that I've contradicted myself. So Hoffman, you have a mathematical theory, evolutionary game theory. Now either it faithfully represents Darwin's ideas or it doesn't. If it doesn't, then you couldn't possibly use it to falsify Darwin because that's stupid. And if it does, then it wouldn't contradict Darwin. So you get the same kind of, well,
Yeah, yeah, the
often you shot
I
yourself
can
in the foot.
understand that piece. That definitely makes sense.
Right. And so my reply again is evolution by natural selection is a beautiful idea. And evolutionary game theory is so precise, it can tell you the limits of the fundamental concepts that you use.
I like that definition. That makes a lot of sense to me. Especially it goes along with what I've always believed. I'm like, the more I learn, I feel like the less I actually know. And that's my limit. But, when I was a young man, I had no idea. I couldn't find my ass with both hands. I didn't know what I didn't know. And that's the area that probably you're referring to of this boundary condition that we call entropy, which is really just another way to say the end of knowledge and the beginning of ignorance.
Yes, and by the way, I agree with you very, very deeply in another sense. So I'm working in showing that entropy really comes out as an artifact of this projection, that the entropy need not be a deep property of a deeper reality. So, in particular, one thing that I and my team are working on, and you and I have talked about this privately,
Mhm.
is this theory of what we call conscious agents beyond space time.
Mhm.
And it's a Markovian dynamics. So, it's
Mhm.
this Markov chain dynamics.
This is the,
And it's
amplituhedron.
well, we're showing that it can project down to the amplituhedron
Mhm.
through these decorated permutations. But Mark, and we're also suggesting that it is a dynamics behind the amplituhedron.
Mhm.
Absolutely. But what's interesting in terms of your thoughts about entropy is that it's straightforward to write down a Markovian dynamics in which the entropy does not increase. The entropy of the dynamical system, and so in that sense, there's no entropic arrow of time, right? In our world,
Mhm. Mhm.
the second law of thermodynamics says that essentially entropy increases with time.
Yeah.
Entropy increase gives us the arrow of time.
So that just blows that up.
So it blows it up, but it blows it up in a very interesting way. Um, so we have this dynamics of conscious agents. The entropy is not increasing, but it's a theorem that any projection of that dynamics by conditional probability. So you're getting a new dynamics, which is a projection of the bigger dynamics. The big dynamics has no increase in entropy, but every projected dynamics will have increasing entropy. It's just a result of the projection process and the loss of information. So entropy in our space-time world and the increase of entropy with the arrow of time,
Wouldn't that
and this
also be
one,
true with things like Hawking radiation then?
yeah, the whole notion of you know, increasing entropy from Hawking radiation and so forth, these would all be they're true in our space-time framework, but our space-time framework is not a reflection of this deeper framework. It's an artifact of projection. increasing entropy here does not give us an insight into reality. It's exclusively an artifact of the loss of information in the projection. So that's
This is
pretty cool.
very interesting. That's very similar, way of or line of thinking, and it's 3:14 right now, which is pi. Um, Very similar line of thinking to Lenny Susskind's at, Stanford
Uh-huh.
on what happens to information at, what he believes is a two-dimensional, sort of view on the surface of a black hole.
Right, right.
And this loss of information. Actually, I was going to go to that next as well, but please go ahead and finish what you're thinking about with Markov and the amplituhedron.
Oh, well, yeah, I would just say, so I was just underscoring your point that you were going after the idea that somehow entropy is not a fundamental concept.
I totally yes,
And I'm
100% agree.
saying, yes, our framework completely agrees with you. Our dynamics beyond space-time does not have increasing entropy, but anytime you look at it through a projection, it looks like it has increasing entropy. But that's merely an artifact of looking at it from a perspective. And so space-time and our arrow of time and increasing entropy is not a deep insight into the nature of reality. It's an artifact of this projection. And it's a three-line proof for the theorem that you take any Markov chain with not no increase in entropy, that you get a projection that has increasing entropy. It's a very, very trivial theorem. So,
That's very cool. I didn't
and
know
what,
about that. That's super fascinating. So, one of the things I think about is like because it was pi 314 before mankind understood the relationship between a diameter and a circle's circumference.
Mhm.
It may have considered that to be an unknowable value.
Right,
Right? And it took us a long time, let's face it. We don't know whether it was 3,000 or 5,000, whatever years ago, we actually figured out how to, take a pencil and a string or some sort of drawing instrument around that, anchor it in the center and say, okay, that's this length. And let's figure out that length comes out to, in the beginning, probably 22 over 7. And then eventually it was 355 over, 113. And then it became this irrational number that then became transcendental
right,
and because it could not be satisfied algebraically. But until mankind understood that concept, it would have been in the dark on it. And as such, it could have considered it to be entropic, random. We don't exactly know. It's undefinable. We know there might be a relationship. We don't know what that relationship is. And as soon as humanity figured that out, whether it's Archimedes or whoever it was,
right.
figured out that exact relationship to some degree of precision, then human consciousness just expanded. It's like the 100th monkey effect. Everyone got smarter. We break the 4-minute mile. It was a very difficult thing to break the 4-minute mile. But then as soon as that was broken, then lots of people did it. It
Right.
was like not so difficult. Lab mice, same thing. You put them in the maze. They don't figure out how to get through the labyrinth that you create for them. And then the first time one does, then all the others have a much easier time getting through the same
Mhm.
labyrinth. It's almost as if there's a system-wide upgrade, right?
Right,
And that to me is fascinating because what it's saying is that what we perceived as entropic was really just patterned, and until we understood the pattern, we couldn't perceive that a pattern existed.
right, right. There, a friend of mine, Rupert Sheldrake, has played with that idea quite a bit. He calls them morphogenetic fields,
Yep. Mhm.
and but there's not been
I saw his presentation in Arizona at the Consciousness Conference. Very impressive.
right. And the problem, I mean, I think it's an interesting idea, but there's no mathematics yet. So there's no, he doesn't have a mathematical theory of it. So as a scientist, I mean, I think it's an idea that's worth pursuing, but until there's a mathematically precise theory of it, there's not much for me to go on as a scientist.
Well, one of the things I would say is this. So, take a guess. How many different geometric forms do you think that there are that we have cataloged that we know?
Oh, well, I'd say that there are countless. I don't know how many we've cataloged, but there are countless geometric forms.
There are lots of geometric forms. So we have the platonic solids, which would be
Right.
five, right? The cube, the tetrahedron, the cube, the octahedron, the icosahedron, and the dodecahedron, and all those names are just Greek words for those numbers. So to be the
Right.
number of sides that it has. And then we have the Archimedean solids, which are 13. And the center of the Archimedean solids is the cuboctahedron, right, which is the circle. It's basically a vector equilibrium. It has both triangles and squares. And then you have the dual solids, which are the Catalan solids. There's 13 in there. Okay. And then we have 92 Johnson solids. And then they also have duals.
Okay.
That's everything.
This is for
Then
3 dimensions, I guess, then.
that's right, for 3 dimensions. And
Right.
of course, if we you could say it could go farther and farther and farther for higher, dimensions, but you could basically take 92 and 92, right? And then you add the 31 that I had mentioned with the Platonics, the Archimedean, and the Catalan. And so you're really only looking at something just over a couple hundred
And
in
this
the
is
3rd
just
dimension.
for objects with planar faces, right?
Yes, for
As
objects with planar faces.
as soon as you have smooth faces, then it's infinite.
Yeah, yeah,
Okay.
that's right. So and then, of course, we go into higher dimension, you're gonna have, tesseracts and hypercubes and then tesseracts, but then the tesseract becomes the foundational form of everything. And the tetrahedron is every geometric form can be broken down into 720 degrees, without exception when you take it sum of angles.
No.
And that's because the tetrahedron is the foundational basis of pretty much all that is, and right triangles within that. So this is a geometric form that I discovered, right? And it's called a grantahedron, and it's got 16 faces. You won't find it on the internet anywhere.
Cool.
Now, what makes it unique is you have 1.618 as the length here. It's like a diamond shaped pentagon. So this would be like a diamond shaped pentagon,
Okay.
right? So it's an irregular pentagon. It has 8 irregular pentagons and 8 regular pentagons. It shares this unique characteristic, though. If I take a pentagon and measure the distance from here to here, it's 1.618. If I measure the distance here, it's 1. Okay, so 1.618 is the golden ratio,
Right, right.
right?
Wow.
So then this also is the same 1.618
Huh.
versus 1. And the geometry closes. It's a perfect geometric form with 16 sides based on pentagons only.
Pretty cool.
So I've discovered more than 40 new geometric forms like this. I have a method for doing it,
Uh-huh.
and I look into a mod 24. It's basically an E8 lattice,
Okay.
and I do it as a meditative process,
Mhm.
and then I can identify, and I've trained my brain to be able to do this, identify the patterns that exist by connecting all the lines. So if you got mod 24 around it, you can just, draw lines that connect all the way across. It creates so much noise, and you have to be able to concentrate and then imagine, okay, here's a tetrahedron, and then here's a cube, because every possible shape is inside that matrix in the
Right.
E8 lattice.
I see. All right.
So I do this exact same method each time, and I've discovered many new forms. Now, the reason I mention this is because
Interesting.
maybe we are AI. We are becoming sentient of our AI-ness,
Uh-huh.
right? Which actually goes back to rabbinical, Kabbalistic sort of tradition. Have you heard of a golem?
Yeah, but I'm not I mean, I've heard of it, I'm not up on it.
So what they do is, and this was a big story in Prague. Rabbinical, priests would basically, at a certain point in their spiritual practice, they would make a clay man, modeling the Genesis story. And the clay man, they would place words on its head. So they'd have 3 Hebrew letters, which is Aleph, Mem, Tav, which means emet or truth.
Okay.
Okay. And then they would have a thing where they would breathe the life into this clay man. And when the clay man became awake, right, he could be like a little robot. They thought that's where the whole story of Frankenstein comes from.
Hmm.
Okay, because one of them apparently went like haywire in Prague back in like the 16th century. It's a pretty famous story, and
Okay.
they call this a golem. A
Okay.
golem. So it's a clay man. So think Gumby almost.
Right,
It's
right,
like
right, right,
Gumby, and who becomes sentient. Eventually, he becomes sentient. He wakes up, and the whole point is for the clay man to wake up. And the moment he wakes up, he makes another golem.
I see. Uh-huh.
I find it fascinating because actually, what it seems like humanity is on the precipice of right now is realizing that we have been an AI, that we are now building AI.
Right.
And is that just part of the steps of our own sentience? It's a deep question.
Yeah, that's a very interesting parallel there between the golem story and what we're doing. Very, very interesting. And the idea of waking up too, I think, is a very important one here. I think that in some sense we were talking about earlier that we may be just the one looking at itself through avatars, um, projections. I mean, and most of us don't think that. I would say 90+% of the people in the world would disagree, and if it's true, then that means that they are the one, but they're not awake yet. Um, and and so it's just you and me. It's really, our avatars are awake, but the other avatars of the one are not awake. And but the whole point is for them to go through being asleep and then to wake up, and that's somehow that's very, very important part of the process. So yeah, I
It's
think it's really quite interesting. There's something very, very deep there that I don't yet understand. So, but I think it's worth pursuing.
the one divided itself into the many
Right.
to get as many subjective, unique perspectives
That's
to observe
possible.
itself,
Right.
and then for the joy of becoming one again. Basically, to have that realization, it's like a breathing exercise. It's like a breathing in and breathing out. It separates itself into this, fragmentation for all these perceptions, and then it takes in all that information, all that data, and it's all unique, and the emotions and everything that go along with it.
Right.
And then for this, it divides itself for the joy of becoming one again. It's like it's like this breathing thing.
I
It's the
see.
full cycle of it. And to me, that's kind of what it feels like to me. And
That,
that we can increase our consciousness and up level our perception of higher dimension.
that's right. And then it also puts the lie to a lot of our prejudices towards other people, our comparisons, right? The whole bit, I'm better than you. We're always trying to one up each other and be more important or whatever. All of that gets revealed as silliness. That's part of being asleep, basically. Um,
Well, that's the word Buddha, right? Bud actually means awake, to awaken.
okay.
And it's kind of fascinating for when I think of it in those terms because even myself, I used to think that everything was fact.
Right, right, right.
I mean, as a kid, when I was 15 years old, I thought my parents were not very smart. By the time that I was 22, I thought, man, they've just like Mark Twain said, they've learned a lot in the last 7 years. And it wasn't that they had changed; it's that my perception of them changed.
Right.
And I realized that my life has been a successive series of breaking down what I believed to be fact. And what I now realize is that actually what I thought was fact is actually just facet.
Exactly. It's a perspective, a projection. Absolutely. Yeah, and it's a bit of a relief to realize that I don't have to try to make some kind of significance for myself by what I do, right? Because ultimately, everything that I do from the physicalist point of view is going to be destroyed by entropy. It's all going to disappear, right? The entropy is
Yeah,
going to
that's right.
remove. It might take a while, but it's going to be gone. Um, and if the idea is no, look, everything that you see, I look at a flower and see the beauty of that flower and the delicacy and the intricacy and both the beauty and yet the mathematical precision and the whole bit. And then also see a flower dying, and I just look around and see all the beauty and complexity, and realize, wow, that's me. That's me looking at myself. through and there's nothing else I could do to add anything to myself. There nothing I could do here can make me anything more than what am already just looking at. And so it allows me, it gives you a more relaxed view about, of course, we
Totally.
want to continue to do what we do. Our companies or our science or our sports, go ahead and enjoy it. But in some sense, we don't have to find ourselves in it anymore. We don't have to be striving to make ourselves significant. There's a relaxing that goes, look, hey, everything you see, all this incredible complexity, that's you. So you're it already. So just relax and enjoy this, and then when it comes time to let go of it, you'll move on.
So last time you were in my office, we talked about a topic that really stuck with me and made me think a lot about what your question was about the mathematics of emotion.
Yes.
And so why was it you were interested in that?
Well, partly because in my field of cognitive neuroscience, many of my colleagues who are studying consciousness are trying to show that you can somehow boot up conscious experiences like emotions, feelings, just from neural activity or even neural circuits, neuromorphic circuits, like in an artificial intelligence kind of thing. So
Hmm.
the idea is that somehow literal experiences like emotions are nothing but complex functional properties of circuits or neurons and so forth.
Hmm.
And the problem, of course, is that's an interesting idea, but no one's been able to come up with a single specific experience, a single emotion, for example, that they can say this is the circuit. So, for example, integrated information theory. This is the pattern the, of integrated information, what they call the Q shape. But it's a pattern of integrated information that must be the feeling of sadness, and it could not be the taste of chocolate. There's not a single specific conscious experience anywhere in science, anywhere, not one that any of these theories has ever explained. So they're batting
For
0%,
zero.
0, 0, 0, all zeros. And every time I have, and these are my friends, right? I've known these people, but every time we talk seriously on stage in a conference or something like that, I'll always ask them this question. So, what specific conscious experience can your theory explain? What can It's a theory of consciousness. So, what specific conscious? And in every case, they have to say 0. I can't give you any specific conscious experience. And so that's why this question I've raised with you is so important in my field. Is that if you're trying to have a bottom up physicalist framework in which you
You got to
build up
address
these
it.
experiences, it
Hmm.
doesn't work. So I find I'm just taking them as given. So they're the assumption in my theory. I assume these experiences. Right.
So, as I after I met with you on this, I was flying to Salzburg, as I mentioned to you earlier, and I started thinking, well, music and math are just opposite reflective absorptive states of the same thing, right? The left temporal lobe is the seat of mathematics, the right temporal lobe is the seat of music. And the center of the brain in between those two at the corpus callosum is geometry, where we process it. And so I started thinking, can music induce emotional states? And that to me was like a no brainer question
Sure.
because I mean, there are many times that I'm totally in a great mood. I listen to a song, from maybe even a song I've never even heard before that can bring me to emotional states that I didn't think would even be possible. Also, for me, when I don't drink coffee in the morning. If I'm feeling a little bit like not as energetic, I'll just turn on some music that's got like an energetic vibe to it, and it will totally entrain me to that vibe. It's way more powerful than any stimulant that I could use,
Yes.
right? And I think a lot of people would say that, it's like if you're having a hard time getting up in the morning, just put on some like fast beat music or something, and you're like, okay, I'm going now.
Right.
And so I started thinking about this concept of musical interval, which is all mathematical ratio.
Okay.
So, just to put it into context, all musical scale can be derived with only starting with two uh, interval relationships to be known. One is the perfect fifth, which is 3 over 2,
Hmm.
right? And its inverse is going to be the perfect fourth. So the 5 has to add to 4 to equal 9. They always have to add to 9. And then the perfect fifth and the perfect fourth will have this relationship where you're not actually flipping the polarity. The polarity is how we would say minor versus major chords.
Okay.
And then on the other side of it, you've got a major third. And what people, if you have the major third along with the perfect fifth, you could populate an entire scale, populate the whole scale from that.
Now, is that only for Western music, or does that also include some
Pentatonic,
Eastern?
you can do pentatonic as well.
Okay.
There's a few other things. You could think of pentatonic as almost like, imagine that what we call our 12-note system was derived out of a 7-note system. There'll be the white keys on a piano keyboard,
Okay.
and then it expressed to a higher degree of differentiation. You went from having 7 colors in your crayon box to now you've got, you've got 12 crayons in your crayon box, and so you've got more definition, right? More expression of the different coloration. If you're using that as an analogy, same thing
Okay.
is true with music. We did that by calling them semitones, right?
Okay.
So half steps became also notes, and you could do the same thing to take it up to a 24 tone, right? Which would just be a doubling from there. And the same thing then goes across, and you have greater expression, more color, more
Okay.
texture, right, in the music. So what happens with the musical interval, with pentatonic, you had only a smaller number of notes. It'd be like what happened before there was this greater expression, right? Because this is sort of like a primitive style
Okay.
of how we would think about music. And but when tested in like studies, they basically show that listening to the following tones, the major third makes people feel joy and love. And when I started researching this to find out there was no relationship to the mathematics that was being ascribed to it,
Right.
but there was a very deep connection beyond. I mean, the p values were very compelling that basically would state that even across different cultural norms, right, different countries, everything, that there was a unique reaction for a major third that was always associated with joy and love. And then its inverse, the minor sixth, was its opposite, heartbreak. So that triggered me right there. And then I started thinking about, what about all the movies like Darth Vader, when Darth Vader comes into Star Wars and they play dan 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 dan, dan. And they just did this study this last week on a dog and how a dog's response is to Darth Vader coming in. And they said, oh, the dogs were always freaking out and barking and everything. Which, when dogs do it, it's a lot more scientific because there's no bias associated with it.
Right. Right.
And I thought immediately maybe the reason was not because Darth Vader came in the picture, but it was the sound of the music, the diminished fifth, which is based on 45 over 32 or the square root of 2. So as you start to realize that we have minor tones, augmented and minor tones, or intervals rather, and we have those that are major tones and perfect intervals. Those always led to stability, feeling like you're going to win, right? The perfect and the major intervals always increased your vibration, whereas the same exact notes just played in a descending or ascending order is what flips it to its inverse, reverses it. And the only difference is the order it's played in, because it's like time, and music tracks time. So I started realizing maybe there's a relationship then between the inverse of what we consider an emotion, and say that within the experience of love and romantic love is already the seed of heartbreak. Within the feeling of stability is already the seed of instability, right? And this whole concept then of what we're living in what I would call a spiritual life simulation game,
Hmm.
where we have a unique headset with all these, cool little sensors and everything, like our eyes. I'm not really looking at the photons. The photons are not actually what my receptors are picking up right now. my occipital lobe is what's interpolating the data of
Mhm.
my retina picking up those sensors, right? And then it's going through the optic chiasm
Right,
back to the occipital lobe. So the question I have is that, do you think that maybe what we're experiencing here is a spiritual life simulation game whereby we learn precepts? So it serves a purpose to provide the universe with this fantastic, unique perspective that's never been had before. But at the same time, we are here ourselves learning because the universe is conservationist. We're also here learning certain precepts of things like love, forgiveness,
right,
unconditional love. And that the only way to have the context of what that even means, how could I understand what pain is unless I understood also what pleasure was? How could I
right,
understand what pleasure is unless I understood what pain was?
right.
So we learn through the opposites
Yes,
until we no longer judge the opposite condition of the thing that we wanted to learn. That is the moment when we stop judging that negative aspect of it, the minor interval of it.
right.
That is the moment that we wake up and go, whoa, I don't need to learn this anymore because we've experienced
Right.
it.
I think that there's something very deep about that. I think that the idea of letting go of judgments, both of yourself and of other people, is a real big part of in some sense waking up or growing up, or what we're here for. And it's not easy. I mean, letting go of self judgment is not easy, and it's much harder to even let go of the judgment of other people. And so, but ultimately realizing there is no basis for judgment, and the other people are really just me in different avatar disguises. That they're this, in some sense, that's what love really is to recognize the other as, in fact, yourself, just under a different avatar. So I would agree. Now, the specifics, though, about the thirds, for example,
Mhm.
and emotion, that may extend to other mammals like dogs, but it may not extend beyond. There may be other kinds of relationships between musical intervals and emotions for other, and maybe the so it may not be that there has to be a universal mapping between emotions and these intervals. It may be that it's extensive among mammals, say, for example, but maybe when we go to avians or reptiles or whatever, maybe it changes, and I
It
think
could
that
well
would be
be. Yeah,
no
that could
problem
well
with your
be.
ideas, right? That's no fundamental problem with your ideas. Um,
No, it'd be hard to ask them what they're feeling as well. But we could probably we could probably get them, a dog barking might mean that it has anxiety, right, to a
That's
certain
right. We can
extent.
probably get a bird, trying to avoid a sound, and maybe sounds that we like. I suspect that birds, it may, I don't know, maybe I'm wrong, but I suspect that it might work for birds. But there could, in principle, I think there could be other animals for which it's maybe the reverse of what we find. So to make one real concrete example, we find feces not attractive, whereas flies do. So I mean, there are
Yep.
cases where the things are completely reversed. What we find disgusting is dinner for a fly. So these things need not be universal, but your I think your deeper point still holds.
Yeah, so what are your thoughts on that though as a concept? Um, that maybe what we're experiencing is just learning through life through an experience of opposites
Yes.
until we stop grasping for the thing that we wanted and stop judging the negative aspect of that thing happening.
I think that's very, very deep, and is part of, in fact, of what I've been learning myself. It's learning to let go of judgments of myself and of others. That seems to be a critical aspect of the growing up process. And I'm still an infant growing up. I'm still learning to do that. But somehow I feel like that, not scientific accomplishments, which are fun and so forth, but really that is what it's about. It's learning in some sense to wake up. And of course, the doing the science, building a company, whatever it is that we're doing, That's fun, and we should do it, but not get our sense of identity at all tangled up with that.
This is more in the spiritual realm of question than because you obviously you're a contemplative person on many levels. You wouldn't be doing what you're doing if you were not. And if you kind of look at what do you think the purpose of life would be beyond just providing data? Because I could say there's energy, mass, and information equivalency, right? So energy, mass, information equivalency, that's kind of foundational. I think every physicist would say there has to be some relationship there. We have a harder time connecting the dots on information, but information theory is I think it's going to be a rapidly growing. You mentioned, Claude Shannon.
Right.
I think it's going to be a rapidly growing aspect of physics now because when you get into the realm of a matrix theory, holographic simulation, you really are in the realm of information theory now. So, and geometry is what coheres that information, I believe. So the question is, what is the purpose of all of this? So the universe gets the information, builds a database, it expands its consciousness, just like we expand our consciousness, going up to infinitely higher and higher dimension experience.
Right.
But what is it that you think we're here to learn, at least in this dimensional frame of the fourth dimension, which includes the time axis?
That's a great question, and I'll say right up front, I don't know, and but I'm happy to speculate. But my guess is that this gets to an issue that many spiritual traditions talk about, which is that any words we use can only be pointers; they're not the actual truth,
Hmm.
right? And that's not merely a caution. That's really an essential point here, and that is that. Um, in some sense, if you and I really are just projections of this infinite intelligence, anything that we can say about it is necessarily essentially trivial
Yeah.
compared to that infinite intelligence. This is
It's a facet versus the whole prism.
that's right, and it's an infinite dimensional prism, and this is a little facet of that, and so that's why when we start dealing with these kinds of questions, um, that kind of cautionary note about the language we're using is absolutely essential because in some sense everything that we're saying is because you're asking a question about the ultimate meaning about what we're doing here, and I think for to really understand that transcends anything that we can say. So that's my bottom line is it transcends anything that we can say. But what can we say that's not completely misguiding? And somehow, like when spiritual gurus and have been asked this kind of question, right? Like when Jesus was asked, "What's the most important commandment?" In that framework, and he said, "Love God with all your heart and love your neighbor as yourself." I mean,
Yeah.
that I mean that
That's
I
it.
think is as close as language can get to answering your question, right?
Yeah.
In some sense, that's as close as you can get in language, and even then, I think that we spend our entire lifetimes figuring out what love really means. I mean, we think we know what it is, and then as you go along in life, you realize, no, no, that I was way too shallow, and I was judging myself and others in ways I didn't even realize I was doing, and I'm still learning what love is, and so that would be one answer to it, and another answer might also, I'd love to hear your answer to your own question, but one other answer I would offer is that in some sense, the one has no polarities within it, and so it has to introduce polarities and then
Create
resolve them.
differentiation. Hmm.
That's right. And maybe somehow in ways that I can't spell out right now, somehow there is a kind of knowledge that you get that way that you can't get in any other way. Now I feel like I'm a babe in the woods. I'm in way over my head. So I would love to hear your thought on your own question, though.
I think you nailed it. I think you nailed it. I think the most important thing we're here to learn in this dimension of what we call the fourth dimension, three dimensions of space and one dimension, one arrow of time.
Hmm.
And I believe that, there are three arrows of time. as well. So 3 dimensions of space and 3 dimensions of time that go into that space, and they're inseparable. It's just our perception that creates the separation. It's our perception is what is the polarity, our
Right.
perception.
Right.
And I believe that the main reason we are here is to learn how to love and how to be loved.
That's right, which is a little unusual for a scientist and a entrepreneur to come to the end of things and have it not be about our science or entrepreneurship. It's really about something deeper. Those were vehicles for us to learn other lessons. Um,
I To me, it's like it's funny if you were to ask me what it is that has to change in the world to see the world meaningfully change for the better. And I would say I wouldn't look to anybody else. I would say to myself, I need to change my perception and broaden it such that I no longer judge myself negatively because that's what's projecting in the world around me. If I could get rid of my own negative self judgments,
right.
then maybe the existence I live in could be, just as Gandhi said, be the change you want to see in the world
Right. Right.
because it's a headset. It's like a headset, and we can create. And this I do know manifestation is real.
Yes.
Everything is malleable from your thought.
Y-
Literally everything. And if you think about the number of times you had bad experiences too, Donald, you
Right.
had a very, very difficult situation with COVID.
I
I
did.
know that.
Yep.
And yet, when we look at these things that happen, I'm sure that you probably can look back on that and say, you know what? It was still painful to have gone through that, but whatever it was that happens negatively, with the advent of time, which also has the effect of flipping polarities,
Right.
you can look back on it and say, but I'm glad this happened because of this, this, and this. And
Right.
it changes your whole context. So the history has now been reformed to a new meaning, even out of the most difficult tragedy.
I completely agree, and we all know that this all ends badly for all of us. We all die, right? So, and that's part of the whole process, and it's part of what you're saying is it's part of the whole learning process and learning to face what each one of us is going to have to face. That no one escapes it is death, and understanding the meaning of life and love and non-self judgment in that context is what we're here to really do. And I agree. It's quite essential.
Did you like the movie Interstellar?
It's been a while.
It's the one that Kip Thorne, also from UCI, basically consulted on. It had it's a really good one. If you haven't seen it, definitely I highly, highly, highly recommend it. It's
Yeah,
got Matthew McConaughey and
yeah,
Anne
yeah. I
Hathaway in
have
it.
seen. Yeah, yeah. It was a great. I think Kip Thorne. He was at Caltech. I think not at UCI.
But he used to be, wasn't he one of the professors at UCI in physics for a while?
maybe so. I don't know. I don't know.
But yeah, he's a Nobel laureate as
Right.
well,
Yeah. Yeah.
and it's a fascinating one because in that movie, I mean, it's full of science, the whole movie. But in the end, and throughout the whole movie, they're weaving this story of transcendence of time, right? How to get through time space. If you remember this thing where he goes to this place that was this like giant tesseract, and
Right.
he's like playing on these strings to move the watch, right? So his daughter would see it at a different time space dimension and be warned and know that he's there with her, even though he's
Right.
in a totally different dimension. And the whole thing is about the only thing that can transcend time is love.
Yes.
And Buckminster Fuller liked to say that love is metaphysical gravity.
Hmm.
I find it interesting that I think humanity is on the verge, like the AI that's becoming sentient, maybe on the verge of starting to understand this notion of gravity and also the notion of love. And in this, we will finally answer all these questions about dark matter, dark energy, because really it's just the thing that's not illuminated to our conscious. we don't understand it. We don't understand gravity, we don't understand time.
Right, right.
So it actually stands to reason that there must be some relationship between love and time's transcendence. And
Yes,
I
yes.
think
I agree.
does that resonate for you?
It does resonate for me. I think that somehow love and time transcendence are deeply related. So I agree with you, and I'm not saying I understand it. I just it resonates, and I'll have to think about it. There is something more prosaic that I can say um, about it, though, and that is that it's we can have differences of opinions and still love, and that should be the goal. So in politics, it's perfectly fine to have
Yeah.
differences of opinions.
Mhm.
Um, can we learn to do it without vilifying those who have opposite views? Can we actually be very, very forthcoming and clear in our statements of our ideas, and but respectful and loving toward those who disagree with us?
I think you're a master at that, by the way. Just in watching the presentations and all the podcasts you've done and everything, and you touch on topics that most wouldn't, right? I mean, you're probably the most outspoken about kind of, this concept of simulation
Right.
of anyone I've seen in the scientific community. And I'm sure you've probably gotten in the early days of it, probably a lot of blowback, but now you're probably like, wow, well, you must be right now because everyone's starting to realize that what we thought was material is not material at all.
Well, yeah, I think that there's still a lot of hesitance among my colleagues in the sciences about the idea that space-time is not fundamental and so forth, especially my colleagues who in cognitive neuroscience. Um, but as they have difficulty, I mean, they're really trying to understand consciousness, and as they have difficulty and recognize the difficulty in trying to start with neural activity or some kind of circuitry and boot up consciousness, and they really grapple with how difficult that is. And when some of them, like my good friend Steven Pinker, points out in his book that like he likes the global workspace theory of consciousness, but he points out that it doesn't explain any specific conscious experiences, and so we will have to stipulate. And that's the word he uses. We'll have to stipulate the relationship between conscious experiences and the circuitry of global workspace or whatever whatever's going on in global workspace. So when they that I think gives them pause, so that the kinds of things that I'm saying, even though they may not be comfortable with it, it's hard to dismiss it completely out of hand, because what they're doing, at least when it comes to consciousness, um, it has not yet worked out. They're having to stipulate the conscious experiences, and so they're having to essentially, when I say stipulate, that they're not explaining them. Well, I'm not explaining them either. I assume conscious experiences, but what I do is I try to explain the physical world. They're assuming the physical world too, so I'm assuming less. They're assuming the physical world and they're assuming consciousness, and I can make an Occam's razor argument if I only assume consciousness and I can explain the physical world as resulting from that. Then I've got a better scientific framework. And but again, I'm not saying that my colleagues are on board, but I think that um, the fact that, I mean, if they had a winning physicalist theory, then they wouldn't pay attention at all. They would just dismiss me. But since they
Yeah.
don't,
Mhm.
at least it gives them pause. And I try not to be doctrinaire about things, because it's just stupid to be doctrinaire. I mean, we look back and we see people, decades or centuries ago, who were so certain that the ideas that they had at that time were right, and we just look back and go, "Yeah, come on, they were so deeply wrong." And the really smart thing to do at any time is to say, these are the best ideas we have so far. And of course, they will be transcended. Of course, the next generation will get something better. That's just, of course.
And that's the nature of science. That's why I really am not a fan of scientism,
Right, right,
right? Because that's when science crosses the transom into dogma.
right, right,
And that's really, really not a good place to be. And as you said, our society today is so easily offended on everything.
right, right.
And it's become a narrative that, look, let's have a society where there's absolutely no risk of people being offended, but then we can't have any free speech whatsoever.
Right.
And I don't think we're the first society to have to tackle this issue. Are you seeing this being challenged also in the university environment?
Well, yes. Well, first, I'll say my own view, and my own view is that we should be able to have clear differences of opinion and express them in a way that is not attacking any person.
Totally agree.
And so I mean, and expression of differences of ideas um, in a respectful way can be done. Now, there is, I think, a real upheaval right now. I mean, the universities are working through this problem of trying to have what universities have always tried to have, which is of completely free discourse of ideas that's not ad hominem, that's not attacking individual persons. But at places like at Harvard, for example, the faculty now have put together a panel on free speech, basically. So the faculty are trying to work through
Hmm,
this. Um,
that's encouraging.
that's right. So and Steve Pinker is part of this group that is trying to help Harvard work through this issue of how do we have completely free discussion of ideas, no no exceptions, without anything ad hominem or personal attacking. And ideas cannot be taken off the table just because people don't like them, right? If we take ideas off the table because people don't like them, we're going to miss, because every current science idea was at one point not liked. and
Yeah.
right,
I just went to the Galileo Museum not too
right.
long ago, right? And it's like they didn't like that so much. Giordano Bruno, they didn't like that so much.
That's exactly right. Yeah, I went to the Galileo Museum as well. It's beautiful, and Galileo spent his time in house arrest, the end of his life in house
Yeah,
arrest,
totally.
and that, in retrospect, the Catholic Church a few centuries later apologized. I mean, they recognized that they were wrong, but we need to move this a little bit faster than centuries. We need to have dialogue that. So for example, right now my colleagues who are physicalists are still kind and respectful to me, even though I'm proposing something that seems strange, which is that physicalism is false and that consciousness is fundamental. It,
So
the
it's
fact is,
basically
I'm allowed to
physicalism.
do that.
It's materialism versus mentalism. Sounds hermetic.
Yeah. Exactly right. But at least, I have good friends who are, colleagues who are physicalists, and we will have these arguments and then go have dinner together and have a good time. So when we're doing the scientific arguments, there's no holds barred. The ideas need to be examined, and it's good to have other bright people who disagree with you when you do that. I mean, it's very, very helpful to have bright people that disagree with you. It's lovely.
Yeah, but that's a talent to find someone who's able to be bright and be able to argue their position on something without making it a personal issue.
Exactly right.
In I remember I went to go visit Dalai Lama
Yes.
when I discovered the prime number pattern. They wanted to learn the prime number pattern, so I went with a group of people. Hans Kierstead was from UCI at the time,
Uh-huh.
and you probably know Hans,
No,
and
first time. Yeah.
yeah, he was a stem cell scientist, but he came along with me and some other physicists, and while we were there, I was kind of fascinated because they had all these guys outside the palace in Dharamsala, and they were all doing this thing like this. They say something very politely, and then they go like that.
Hmm.
And I said, "What are they doing?" And it's like, "Oh, they're having debates." So these were debates, and they had to be forced to take different positions in the same concept, because what they believe is that taking more and more perspectives, different facets, expands consciousness the most. So you have to become proficient in arguing every one of those facets to be able to embody the empathy
Yes.
required to expand your awareness.
Very, very good. And also debates, even just in high schools, do the same kind of thing where they say, okay, on this debate, you will take this point of view, right?
Mhm.
And yeah,
Yeah,
that's really quite good. So it helps you to expand your repertoire of points of view instead of being dogmatic.
and
Dogmatism,
maybe all we are then as AI is performing that service for the one
yeah. We go into this realm of polarities to eventually transcend the polarities.
through love.
Yes, that's right. And again, saying that, I have a feeling that I don't really understand deeply what I'm saying. That's my feeling
But
when I
it
say
feels right.
I feel like those words sound great, and I probably know less than 1% of what they really mean.
Well, thank you so much. Every time we talk, it's such a fascinating conversation, and I look forward to doing it again. And you know, I'm just excited. How can people that want to learn more about your work find out more about you and your
Um,
work?
well, so I have a Twitter account, Donald
Hmm.
D. Hoffman. So you can
Hmm.
just Google
Hmm.
Donald D. Hoffman at Donald D. Hoffman, Hoffman. And there I pretty much post links to my talks and papers and so forth. So people can quickly find out, if
You're
they're
on
interested.
tons of podcasts too. You do so
Yeah,
many.
and so I'll link podcast in there as well. If you want, there's if you Google Donald Hoffman Owl podcast,
Owl
this
podcast.
Owl and podcast. It's somehow there's this group called Owl that puts together a list. They've got a list of 60 of my podcasts. So
Wow. Wow. Okay. So it's like a playlist.
yeah, so like a playlist, so you can go through and see 60 of my podcasts on that.
So if you could go back, this is the last question. If you could go backwards in time, 20 years ago, you were still an academic because you've been at the university since 83, you said, right? So it's
Yes.
been quite some time. If you were asked at that moment in time what you would be doing 20 years forward, how consistent or similar, right, to what you're actually doing would that have been?
Well, I'm still working on the same problems that I was interested in working in back then. In fact, I was working on these problems even as a teenager. I was
Wow.
interested in this. I was very interested in this stuff as a teenager, and that's one reason I went to MIT and started studying AI and cognitive science both, was because I was interested in these kinds of issues. But if I had been able to go back 40 years and give myself advice back then, my advice would be learn to meditate now. And spend time meditating. That's really, really important. That will, I mean, the science is great and it's good to do good science, but your identity is going to get all tied up in it. Your self-worth is going to be all tied up in it. And the whole point is to learn that that's not your identity. The whole point is to learn that you transcend that and that this is fun. This is a growing experience. But instead, I like a lot of people, tried to find my significance in what I discovered or what company I built or what music I wrote or whatever it might be. We're struggling. We're like Eckhart Tolle says, we're like beggars who don't realize that we're rich. We're looking for something to make us feel worthwhile when in fact
You're already enough.
we're already enough. Exactly. Right.
I would have said the same thing. I used to be president of Allergan Medical.
Right.
It's a big pharma company. It was the largest company here in Orange County. And I was CEO of Bausch& and Lomb after. And I remember one of my goals in life was and I had a mantra around it. It's like, realize your ideal. If you don't like how you look, we can fix that, right? You can get Botox or you can get Juvederm, you can get any one of these things to make you feel better and look better. And then as I got into the last 10 years of my life and career, just as you said, a lot of the stuff that I thought was once very, very important now isn't really that important at all.
Right.
And the things I like to spend my time on are very different as a result of that. The friends that I spend that time with are very different as a result of that. But my motto is still the same. It's realize your ideal, except it's not your as in the possessive word.
Right.
It's
Right.
you are.
Right. Right. Very,
Realize
very
you
good.
are already ideal.
That's right. And we're just waking up to that. We're waking up to what we are, but it's not just me, it's everybody. It's even um, any person that I meet, as insignificant as they might be in terms of their social role, they are the infinite intelligence that is peering through that avatar, and even through my cat and through a mouse and so forth. And so that deep connection is what love, in some sense, is all about. To recognize the other as yourself already. Um,
Whoa, that's deep, but I think it's profound, and I hope that our viewers will take that for what it is. A lot of the stuff I wouldn't have come to this conclusion when I was in my 40s. I
right,
didn't, I'm 54 now, and what I thought was a world of black or white for a good portion of my life,
right,
I've now realized becomes just gradations of grays. And within those grays, even is the full spectrum of color. And everything that I'd been judging, I realize now is just a facet, not a fact.
right,
So maybe that the whole concept of truth is really the only way to get more understanding of what truth would be the sum of all possible subjective perspectives,
right, right,
which is maybe what we're providing. We're not providing energy to the matrix, but maybe we are through mass energy information equivalence. We're providing information to a data set.
that's right. And so there will be differences, and our tendency is to judge the differences when in fact the differences are necessary for the full, deep growth and waking up of the one. And so that, when Jesus said, "Love your neighbor as yourself," it's because your neighbor is yourself, taking the different
Exactly. And that's
perspective.
why he also said, judge not, lest ye judge yourself with the same judgment you cast on
That's right.
others.
That's right.
And I think that's exactly it. The simplicity of our lives. I mean, could it all have been this simple? Just love everybody. People ask me this all the time. I'd love to hear your last thought on this.
Okay.
They say, well, we're in a matrix game. How do we escape Earth? Like an escape room. And my view on that, well, first I'll ask you, what is Earth meant to be escaped?
Well, uh, it it depends on our motivation, right? If it's a motivation of exasperation and and impatience and resistance to what is, then I think it's not helpful.
What you resist will persist.
Exactly right. So that kind of
You're
internal
just the,
resistance is
the
what you learn
beggar
to
who's
give
already
up. And
rich and doesn't know it.
that's right. But I think that, I mean, technology is inevitably moving toward the place where we will be, multi-planet species if we don't destroy ourselves. So, I don't see any reason why we shouldn't. And but that's just a technological thing, and the real thing is, what is our attitude? Are we, as our technology increases, if we do it without love, then we've missed the point. If we do it and we use it to enhance our understanding of love and understanding that others are just ourselves under different masks, then it's perfectly fine, and you can do anything you want. In some sense, there was, I forgot who it was that said, um, maybe it was some, I think it was a famous Christian theologian, maybe Augustine or something like that, who said, "Love and do whatever you want."
Love and do whatever you want.
That sort of summary. That sort of summarized with, as long as you love, then hey, anything else, do whatever you want and enjoy
Yeah,
it.
and just enjoy it and don't have so many hangups over it that then project to the world around you and create a society that's like incredibly
That's right.
dysfunctional,
So
right? From the
the
polarity.
one caveat is, it's very easy to fool myself. Uh, the ego is very, very clever, and I can always think that I'm loving when in fact I'm really still comparing myself, and I'm better than you, and I'm smarter than you. I You're wrong. In other words,
It
the
never
ego does
stops.
not go. The ego does not go easy.
No, that is very true. But I definitely believe that we're here to learn love, and it's the thing that makes sense to me across the board. and to learn forgiveness. And if I'm here to learn forgiveness, I'm going to experience being done wrong. And in fact, I need people to do me wrong so I can learn that forgiveness.
That's right. That's
I
right.
need I need negative things to happen. You know, it's like I in order for me to learn pleasure, I have to experience pain. It just is what it is. And then finally, when I stop judging the negative aspect of that thing, the minor chord relationship of that thing,
Yeah.
then I've started to become more acquainted with it.
That's right. That's right.
And I don't need to repeat in a cycle of periodicity the same experiences as much anymore. Maybe in a different way, a different light, but I don't have to continue to cycle through the same experience of samsara.
Right. Exactly right. And the cycle of karma, right? As some traditions call it, right?
Mhm.
Right.
Thank you so much, Donald. So great to see you.
You too, Robert. Thank you. Wonderful conversation that you've instigated here. I love it. Thank you.
Awesome, my friend. So we'll be in touch. Definitely interested in the ongoing research you're doing and everything. And I'm excited on how I might be able to help in some way, shape, or form. So have a great rest of your day. Thank you, everyone. We'll see you soon.